products and services and solutions that are all based on RISC-V. It's really amazing to see. So what we thought we'd do with this 45 minutes is bring together some really interesting companies and members from around the world, different geographies who are doing amazing things with RISC-V, and they're going to each introduce their products and services to you and show them what they're all about. So I'd like to start off by introducing Bilal from 10x Engineers.
A wise man once said to me, Bilal, never stand between people and their food, or they will eat you. So as the last panel, or the last session before the lunch on the last day, I apologize. But I'll try to make these 10 minutes, not the most boring 10 minutes for you at the summit, by talking about how we have tried to combine services with open source contribution to enable innovation in RISC-V. Hi, I'm Bilal, co-founder of 10x Engineers. First, an introduction of 10x Engineers. So we're a services company, which means that we don't have products of our own. We help our customers build their products. We help them build products in two areas: camera ISPs, specifically for computer vision, and RISC-V. We have a team of about 80 engineers, and we started about 3.5 years ago. So really excited to be here in Europe for the first time. So most of our customers come to us with problems. And those are their problems of today. In the last 3 days, we have seen that the evolution of RISC-V is at a stage where we're really trying to build high-quality, really performant RISC-V IPs. So what is the problem that our customers are bringing to us? Well, design verification is one, compliance with RISC-V specification. Those of you who are familiar with verification, this is your typical writing UVM test benches, writing tests, closing coverage, and all of that. We help our clients do that so that they can get to market really quickly with really high-quality products. The second area where we help them with is RTL design. So this is them building their IP. It could be within the core or on-core blocks, and we help them do that design and implementation, whether it's for FPGAs or ASICs. And finally, compilers and tool chains. No project is complete unless you can generate software for it. So we help our clients on the compiler side, specifically on LLVM, and increasingly we're seeing MLIR as one of the compiler flows that our customers are asking for. So very early on in our journey, we asked and we committed ourselves that we're not going to be just takers from this open source community. That we are going to contribute back. This is back when we were like a 10, 15-person organization. And we decided that we're going to commit our time and resources to contributing back to these open source projects. That was a decision that was made very early and has become part of our DNA. The effort started as some random tasks that we pick up, but thanks to help from partners in open source, RISC-V International, Jeff, and in the open hardware community, Flo, Jean-Roch, thanks to those efforts, these projects matured, and our contributions also started to mature. Our team started to learn. Today, Umar from our team is one of the maintainers of the architecture test repositories. Fatima, sitting right here, she's one of the maintainers of the open hardware repositories, working on CVS6. And Ali, he maintains our repositories for Cloud 5. I'll talk more about that. And that's what Calista talked about, our 10x Engineers being a lab partner. Ali leads that front for us. Now, each one of these are our 3 anchors. They help other team members contribute into their respective projects. Other team members come in, pick up a task, deliver it, and move on. But these 3 steer that effort and stay connected with that community. So that's where our open source contributions are today. Now, we asked ourselves this question, and it was partly inspired by our contribution to the open source. What are tomorrow's problems of our customers that we can try to help them solve? And the answer was obvious. Software, software, software. That's when we started working on a cloud-based platform that enables software developers to build their software on RISC-V. That's what we call Cloud 5. You can learn more about it at cloud5.co, but it's a cloud-based continuous integration and sandboxing environment for RISC-V application development. The basic software stack, your language compilers, your build tools, your foundational libraries are pre-installed, so you don't have to worry about cherry-picking the right commit. You can be on your way to development very quickly. Once you've compiled, you can run these applications on emulated QEMU instances or real RISC-V development boards, the Hi5 and the Vision 1 and 2. And that list keeps growing as we go along. The platform is free to open source communities. So anybody here that's a contributor, maintainer to an open source community and wants to port your application to RISC-V, please log on to cloud5.co and let's do this together. We can even help you port the software if that's what you need. The tools that are available today, if you're interested in details, it's an ever-growing list, so you can always go and look at the latest, and this is not complete. But like I mentioned, it's your language compilers, it's your build tools, and tool chains. Some runtimes as well. So, open invitation to all developers. It's not perfect. It's an evolution. It's in its first phase. But if you want to contribute, or if you want to build on top of it, please join. I was really happy to see Rise present here, Larry spoke, and then the Vitamin V team that's doing a great work in trying to port the cloud stack to RISC-V. And then we're hoping that we'll sort of build on these efforts and essentially accelerate software development on RISC-V. So that's what we're doing. But before I leave you, I have one more thing to say. So if you think back to the time that you were first introduced to and got excited about RISC-V, it wasn't just because the specification was open source. It was also because high-quality open source implementations were available for you to just download and run. Whether it was the Rocket or the Boom from Chris's team in Berkeley, or the Swerve family, of course, from Western Digital, or Florian's Ariane, for the first time, it felt like microarchitecture was accessible. It wasn't just a thing that you read in a textbook with block diagrams. It was something you could hold in your hands and tinker with, maybe even improve. So to me, the future of RISC-V, yes, it's open standard, a global standard, but it's also high-quality, open-source IP that's freely available. That ushers in a new era of innovations. That allows developers, that allows the next generation of developers to build products that we can't even think about today in this room, using those building blocks that we're building today. Frankly, that's what got me interested and excited after 10 years in the industry. And I hope that was the same for you as well, for many of you with white hair at least. So where are we now? Going forward, I know I speak as an outsider, but I think Europe has to lead in this. We have to fund, we have to develop, and we have to maintain high-quality IP so that startups tomorrow can use it. And not just because of European sovereignty, but also so that little kid inside each one of us is excited and hopeful. And for the next generation of Roger Espazas and Krista Isanovich to be inspired to build on our shoulders. Well, thank you very much for your time and attention.